One, two, three. One, two, three, go.
Our topic is other chi-square test. This is our outline.
Karon na.
We have two
Okay,
outline.
outline. Okay muna.
Di, kung ano, ta ka ng...
Di na lang ikat on.
Ang introduction ba, ka ng dili...
Na.
Okay, pause din na.
Wa gud to gano.
Yung magkwento mga bloopers pagka last.
Nang nilito.
Kumadi naganda din.
Oh, kamot ni Tia.
Ako nalit. 1, 2, 3, go.
We are part 12 and our topic is other chi-square test. Our outline is test for goodness of fit and test using contingency table. Learning's objectives. Test this for goodness of fit using chi-square. Second, test two variables for independent chi-square. Test proportions of homogeneity using chi-square. Test for goodness of fit. The chi-square statistic can be used to see whether a frequency distribution fits a specific patterns. This is referred to as the chi-square goodness of fit test. Observe unexpected frequencies since the frequency for each flavor were obtained from a sample list. Actual frequencies are called the observed.
So for example, we have fruit soda flavors. So we have 5 steps na susundin. So step 1 is state the hypothesis and identify the claim. So step 2, find the critical value. And step 3, compute the test value. Step 4, make the decision. And step 5, summarize the result. So, a market analyst looks to see whether consumers have any preference among 5 flavors of a new fruit soda. A sample of 100 people provided the following data. Is there enough evidence to reject the claim that there is no preference in the selection of fruit soda flavors using data shown previously? Let A is equivalent to 0.05. Example flavors are the cherry, the strawberry, orange, lime, and grape. So, observe, 32 ang sa cherry, and then strawberry is 28, sa orange is 16, lime 14, and the grape is 10. So, expected is 20 sa cherry, sa strawberry is 20 din, orange is 20, lime is 20, and grape is 20 din. So step 3, compute the test values. So step 4, make the decision. The decision is to reject the null hypothesis.
Hello, I'm Jennifer Singson and I'm here to report the example 12-2 as the education level of adults. So, the Census Bureau of the U.S. government found that 13% of adults did not finish high school. 30% graduated from high school. Only 29% had some college education but did not attain a bachelor's degree, and 28% were college graduates. So, to see if these proportions were consistent with those people who live in the Lincoln County area, our local researchers selected a random sample of 300 adults and found that 43 did not finish high school, 76 were high school graduates only. At A equals 0.10, test the claim that the proportion are the same for the adults in Lincoln County as those. So, to find out the education level of adults, we have 5 steps to follow. First step is state the hypothesis and identify the claim. Step 2 is find the critical value. Step 3 is compute the test value. And step 4 is make the decision. And step 5 is summarize the results. Step 1, state the hypothesis and identify the claim. So each sub O, the proportion of people in each category is as follows: 13% did not finish high school, 30% were high school graduates, only 29% had some college education but did not graduate, and 28% had a college degree that are claimed. Then H sub 1, the distribution is not the same as stated in the null hypothesis. Then step 2, find the critical value. So since A equals 0.10 and the degrees of freedom are 4 minus 1 equals 3, the critical value is 6.251. So step 3 is compute the test value. So first, we must calculate the expected values. Multiply the total number of people surveyed, which is 300, by the percentage of people in each category. Okay, step 4 is make the decision. So since 3.531 is less than 6.251, the decision is not to reject the null hypothesis. So we can see the figure 12 thus 4. Step 5. Summarize the result. There is not enough evidence to reject the claim. It can be concluded that the percentage are not significantly different from those given in the null hypothesis. That is, the proportion are not significantly different from those stated by the U.S. Census Bureau.
Good day. Today si Gio Castellano. My topic is, it's all about firearm deaths. A researcher read that the firearms-related deaths for people aged 1 to 18 were distributed follows: 74% were accidental, then 16% were homicide, and 10% were suicide. In her distinct, there were 68 accidental deaths, 27 homicides, and 5 suicides during the past year. At 0.10, states that the claim that the percentage are equal. In the table, they have observed, then expected. Then expected is equal to 100%. Then the observed, 68, 27, and 5. Then step 1, state the hypothesis and identify the claim. H initial deaths due to firearms for people aged 1 through 18 are distributed as follows: 74% accidental, 16% homicides, and 10% suicide claim. The distribution is not the same as started in the null hypothesis. Then based on the table again, makita nga to ang ang ilang observation and expectation. Then sa step 2, find the critical value. To solve chi-square test based on my topic, it's about firearm deaths. Step 1, they have observed and expected. The 3 category: accidental, one is homicide, last one is suicide. based on the table at my report is 68 accidental, 27 suicide, 5 suicide, then 74% accidental, then 16% suicide, 10% suicide. Step 2, find the critical value. Find the critical value. The DF means number of category minus 1, then number of category accidental, homicide, suicide 3 minus 1 is equal to, then and alpha the given is 0.10, then critical value 4.605. Step 3, X squared submission of observed minus expected squared over expected. Muna ang formula para makuha nga tong ang iyang sa pagsabot kung sakto ba ang iyang pamagi. Natay 68 minus 74 squared over 74 based on formula plus because for homicide 7 minus 16 squared over 16, then plus based on suicide over 10 equal 10.549. Step 4, answer based sa problem na ito nga ganyan katong 3 category 10.549 is less than sa atong gigamit nga critical value nga 4.605. So muna siya ang kuan sakpan na to ang iyang kung tinuod ba nga 74% ba jud ang accidental or 16% ba jud ang homicide, din 10% ba jud ang suicide. Then step 3, compute the test value. So kani nga formula again unya ako na pud ni solve balik. Step 4, make the decision. Reject the null hypothesis since. Then step 5, summarize the result. There is enough evidence to reject the claim that the distribution is 74% accidental, 16% homicide, and 10% suicides. Then sa lahi nga option natay kuan nga gamit ta og test for normality, then kaduha test using contingency. So para makasabot ako kung unsa ni siya ang normality optional, base ra gyapon ta sa atong report na the chi-square test goodness of fit test can be used to test a variable to see if it is a normal distributed. The hypotheses are initial age of the variable is normally distributed, then the final is the variable is not normally distributed. The procedure is somewhat complicated. The calculations are shown in example of 12-4 on page 616 in the next topic na using the contingency tables when the data can be tabulated in a table form in terms of frequencies. Several types of hypotheses can be tested by using the chi-square test. The test of independence of variable is used to determine whether two the variable are independent of or related to each other when a single sample is selected. The test of homogeneity of proportion is used to determine whether the proportion for a variable are equal when several samples are selected from different population. Test for independence. The chi-square goodness of fit test can be used to test the independence of two variable. Kailangan natin duha nga variable. So the hypotheses are H initial, there is no relationship between two variable. Muna siya ang atong initial 1. So ang initial 2, ang final initial here, there is a relationship between two variables. So makabalo na ta kung unsa independence, kailangan ang usa relation ng usa without relationship. And the null hypothesis, there is rejected. There is some relationship between the variable. Test for independence. In order to test the null hypothesis, one must compute the expected frequencies assuming the null hypothesis is true. When the data are arranged in a table form for the independent test, the table is called the contingency table. So, basta ang arrange ganyan yung data from the independent test in a table, man na siyang itagog contingency table. So, kaning contingency tables, man na siyang na siya'y column. Depende pila siya ka column 1, column 2, column 3, then row 1, row 2. So, ako ni siya ipakita niya og yun sa ni paggamit sa contingency tables, the degrees of freedom for any contingency table are different. So, magamit ang formula pagkuha sa contingency tables. Row 1 minus 1, then column 1 minus 1, muna siya ang pagkuha sa contingency tables. So, test for independence, kaning formula, the formula of the test of independence, ako ipakita niya, then test for independence, x squared is equal to summation of observed minus expected squared over expected. So DF means number of category. So kay independence naman ta, gamitan na is row minus 1 times C means column minus 1, then observe, O is observed frequency, then E expected, see, to solve expected frequency, the formula is row sum tanan row times tanan column over the grand total. Then to solve the siyang test for independence, then to solve the contingency table, okay sample pero magamitan niya siya sa sunod na mo report. contingency table. DF equal to row minus 1, then column minus 1. Ano na siya? Ang si Geomark Stiliano nag-report sa independent test, then contingency table.
Example 12-5. Sports preference. A researcher wished to see if there is a difference in the favorite sport of males and the favorite sport of females. She selected a sample of 32 males and 48 females and asked them which of three sports was their favorite. The results are shown below. Step 1. State the hypothesis and identify the claim. H0. Sports preference is independent of the gender of the person. H1. Sports preference is related to the gender of the person. Claim. Step 2. Find the critical value. Find the critical value. The critical value is 4.605 since the degrees of freedom are 2 minus 1 times 3 minus 1 equals 2. Compute the expected values. You can see the formula at its screen. About alcoholic consumption, gender low, moderate, high total, and the number of males and females and its total. And step 3, compute the test value. And step 4, make the decision. And the last, step 5, summarize the results. Test for homogeneity of proportions. Homogeneity of proportions test is used when samples are selected from several different populations, and the researcher is interested in determining whether the proportions of elements that have a common characteristic are the same for each population. Test for homogeneity of proportions. The hypotheses are H0, P1 equals to P2 equals P3 equals to P4. H1. At least one proportion is different from the others. When the null hypothesis is rejected, it can be assumed that the proportions are not equal. Assumptions for homogeneity of proportions. 1. The data are obtained from a random sample. 2. The expected frequency for each category must be 5 or more.
Guwapo.
Makuha ni mo.
Okay naman din ang video.
Take
Jesus po Ginoo.
Uy, nag-video na dahil na.
sa video na ba? Mukbang
I will give you one example of this part. Cut.